All right, welcome back. I am Dr. Boyd, the chemist, and today we are going to make a cloud in a jar. Cloud in a jar, and what you will need for today's lesson is you'll need a clear jar, one with a lid. You're going to need some kind of lid, an aerosol spray like hairspray, and I know Lysol is really a hot commodity right now, but Lysol will work. You don't have to use a lot of it, just like a little quick spray of it. Ice, and you'll also need some hot water. Doesn't have to be boiling hot. Just hot water from your faucet should be fine. And I want to mention the lid for the jar. You should have it in the freezer because you want it to be cold. All right, and we'll pull that out just before we do the experiment along with the ice. Okay, so we'll get started in about a minute and a half or so. All right. Okay, so welcome back. And again, I'm Dr. Boyd. And today we are continuing. This is lesson 15. Can you believe this? The end of the third week of these lessons. So we are finishing this week dealing in the area of weather. And specifically, we're going to talk about clouds. So to start, I did want to just give a definition of the area of science that deals with weather. It is called meteorology. Meteorology. We're most familiar with the weatherman or the weather lady on television during the news giving us the weather report. We call them meteorologists. All right. You don't have to be on the news to be a meteorologist, but that is the profession that we are most familiar with underneath the subheading of meteorology. But meteorology is the branch of science that does deal with the weather. And today we are making a cloud. So as I mentioned before, we're going to be using a jar. My jar has a lid, but I have my lid in the freezer right now because I want the lid to be cold. It will make the experiment or the demonstration go much easier. And then also I have some hairspray and I do have some Lysol spray over here too. And you're going to need ice. And we're going to make a cloud in this jar. So well, I guess before I get started talking about that, we're going to talk about safety as we do each time. Now, you know that safety is the most important thing that we should be considering whenever we do an experiment. Whenever we do an experiment, we always want to consider safety. And typically, we talk about the fact that you should protect your eyes and your hands, and you should protect your body with goggles, gloves, and a lab coat. And that is very important. Now, I won't be wearing any of those things today, but there is a safety hazard in this demonstration. In fact, there are two potential points of safety hazard. The first one is we have these aerosol sprays. Now, for the most part, they're safe, but you do want to keep in mind that you don't want to spray this in your face or at somebody else. Okay, so we want to be careful when we're using the aerosol spray. We don't want to harm anyone with it. Okay, that's the first thing. The other thing that may be a little more obvious is the hot water. You don't want to burn yourself with the hot water. Okay, you don't want to burn someone else with the hot water. So you have to be careful handling the hot water. Anytime you're dealing with hot water, you want to be careful handling it because you can burn someone or even yourself We want to be careful about that. So safety isn't just the wearing of personal protective equipment. It is also being aware of safety hazards, like in this particular demonstration, hot water and aerosol spray cans. Okay? So, did want to get that in? You have your notebook. Dr. Boyd has his. Do you have yours? Okay? So, in my notebook today, this day 15, I have the date written down and I have the topic written down. And the topic is cloud in a jar. So, make sure you write that down. Cloud in a jar. Cloud in a jar. And I mentioned earlier that the area of science that deals with weather is called meteorology. This is how you spell that word, all right? Ology, that ending, that stands for the study of, the study of. So you could look at it, it might translate in your mind to the study of meteors, all right? Or the study of weather, essentially, okay? So we are dealing with clouds, and ask yourself a few questions and write these down. What is a cloud? What is a cloud? All right, have you ever seen one? Where do clouds exist? All right, I'm certain you've seen the clouds before, and in fact, you probably know exactly where they are. They're up in the air, right? So clouds are these they look like big cotton balls floating around in the air, right? So clouds are in the air. They're floating around in the air. Now, what do they look like? What does a cloud look like? Okay, there are many different types of clouds. Some of them indicate that the weather is nice. Others indicate that the weather is not so nice. So there are cirrus clouds and there's stratus clouds. And those clouds, when you see those, the weather is probably going to be pretty nice. Cirrus and stratus, and even cumulus clouds. Those are a little more puffy. Cumulus clouds. But when you start seeing cumulus clouds and then they begin to build a little bit more, we have names like cumulonimbus. Maybe I'll write a couple of these down just so you can look it up for yourself. So if you ever study clouds, you will know that there are lots of different types of clouds. And I just listed a few of them. So I'll write them down here. Hope I spell them all right. Cirrus and stratus. Again, I think I have these spellings right. And cumulus. All right. Cirrus and stratus and cumulus. And I mentioned when you see a cirrus cloud or a stratus cloud, the weather is probably pretty nice. Cumulus clouds, the weather might be fine. But when you start getting them together long enough, you start getting clouds like cumulonimbus clouds. Hope I spelled this right. If not, you probably can spell check me and you'll figure out what it is. If you check it out online, Google it perhaps. So, cumulonimbus. All right. Cumulonimbus, now you're starting to talk about what we would consider a storm cloud. A storm cloud. So, and these clouds can get really big and very tall and high up in the atmosphere. All right. So what else do clouds look like? They can look like a feather in the sky, or they can look like big cotton balls in the sky. They can be white in color. They can also be gray in color. They can also be very dark, like almost black in color. All right. Well, what does that mean? That gives us some indication of the kind of weather that is approaching. For example, yesterday I was sitting at my dining room table, as I am right now, and I looked out the window and it was sunny, but I saw in the background the sky was looking gray and there were gray clouds in the sky. And that suggested to me that the weather was going to get bad. And sure enough, a few minutes later, it began to get very, very windy, and then it started raining pretty hard. Okay, so the clouds give us some indication of the type of weather that we will be experiencing. Okay, and clouds can be white, they can be gray, they can be very black, it can be very dark. I'm from the Midwest, and I've seen many thunderstorms. In fact, driven through some storms that have spawned tornadoes. And those clouds are not very nice to look at, and they are quite scary. So we know that clouds give us some indication of what the weather is going to be like. All right, just looking up at the clouds. How do clouds form? That's a question to write down. How does a cloud form? Where does it come from? What is a cloud made of? What do you think? All right, so clouds are actually made up of really tiny, small droplets of water vapor, okay? Or they can be made up of ice crystals. If the weather is cold enough, they could be made up of ice crystals. Now, the cloud actually forms, however, when that moisture gets up into the atmosphere and interacts with dust particles that are also in the atmosphere. That dust particle attaches itself to some of the water or the ice droplets that are in the air, and all those dust particles and water droplets in the air next to each other, they begin to form a cloud. They form clouds. All right. So you can actually watch a cloud form. I have spent many days just looking at clouds, watching them get bigger and bigger and bigger. And then sometimes I've watched clouds get smaller and smaller and smaller and ultimately disappear. What happens in the atmosphere when this big cloud gets big enough and full of enough water or ice crystals, what we call precipitation begins to fall from the cloud. Precipitation begins to fall from the cloud. That precipitation comes down in the form of rain or snow, all right, out of the cloud. So that moisture has built up enough that it can no longer be contained in this big old cloud. And after a while, the moisture comes out, and it comes out in the form of rain or snow, for example. Now, believe it or not, clouds are actually very, very heavy. At least we calculate the weight of a cloud to be very heavy, despite the fact that it floats. So if you were able to pick up a cloud, believe it or not, you'd be a really, really, really strong person, perhaps the strongest person in the history of all mankind. They're quite heavy, and it's a bit of a conundrum, but it is true. Okay, so what are we going to do today? We are actually going to make a cloud in a jar. So I have my wonderful jar here. This is an old, I think, spaghetti sauce jar, and it's transparent. I've cleaned it out, and it has a metallic lid to it. I think that works perhaps the best. What I'm going to do is I'm going to take some water and fill it almost halfway. The water will be hot, okay? Now, you don't want the water to be too hot. And the reason you don't want the water to be too hot is if it's too hot, what will happen is you'll see condensation on the inside of the jar, and it'll look as if it's cloudy. But that won't be the cloud. That will just be condensation. When I say condensation, that's moisture that has gone back now into being like droplets, really tiny droplets of water. Okay, you will see that along the edges and the sides of the jar. If I put water in here that is too hot, you'll probably see a little bit of it anyhow. But if you put the water in and it's really too hot, you'll see only that. What I want to see, however, is a cloud forming. So what's going to happen is I'm going to fill my container about halfway with some hot water from my faucet, and then I'm going to spray into the jar just a little bit of spray. Why am I putting the spray in there? What effect does the spray have? I actually explained already the concept. And so I just want you to think about this for a moment. I said I'm putting hot water in here, and I'm going to then spray the aerosol can in there. I'll continue explaining. After that, I'm going to take this cold metallic lid, place it on top, and then we're going to put ice on the lid. Now, I mentioned I'm putting the lid on top. I'm actually putting the lid on top upside down so that I can put the ice in it, and that way I don't have water running everywhere. You'll see. So why do I spray the aerosol spray into the container before I put the lid on it? What effect do you think the spray is having? What part of the formation of a cloud is the spray providing? Think about that for a moment. I'll give you about 10 seconds to think about that. Okay, I hope you've thought about it. So let's rewind. I said that clouds form from moisture that gets up into the atmosphere. And the moisture in the atmosphere connects with dust particles in the atmosphere. And from the combining of these dust particles, we get nucleation, and then we get propagation of more and more moisture and dust particles together. And that's where you build your cloud. So the function of the aerosol can is to provide dust for my cloud to form. All right. In the absence of the aerosol spray, all I'll be seeing is condensation, and that is not the same as cloud formation. All right. Now, before we do this, we're gonna start this in just a few moments, but I do want to say on the video that you have on the live stream, it may not be obvious or apparent to you what is going on inside of the jar. So I hope you'll be able to see it. If you are unable to see it here, I do have a video of this on my YouTube channel, and you can clearly see the stream of the cloud forming on the inside of the jar, in case you are unable to see it today. So find me at Dr.Boyd, the Chemist on YouTube. Definitely subscribe and look up cloud in a jar underneath my videos, and you will see this example there. What you should see, if you're able to see it on the live stream today, what you should see is I'm going to put the lid on, and towards the top, you'll start to see like there'll be these lines of white dropping down from the top, I guess from the lid, from the inside of the jar down into the jar. And that is actually the cloud forming, which is different than condensation. The condensation, you would see it aligning along the edge of the jar and maybe at the top, and it would just stay there. But the cloud, you'll see it. It streams down. And again, if it's not visible on the live stream today, definitely check it out on my YouTube channel. I think this is one of the cooler demos I've done that I've posted there. And I hope that you're able to give this a try at home as well. Okay, so we're going to get started. I'm going to get my hot water, and I'm going to fill this up. Here's my water, and I'm going to go grab, I think that's hot enough. Yeah, that's hot enough. Grab my ice. And my lid. Okay, so again, I have a lid that goes to this container. Normally you put it on like that, but I'm actually going to flip it upside down when we get started on that portion of it. I have my ice cube. I'm actually probably going to use a couple ice cubes here. All right, because I want to keep that lid cold because I want the water vapor to get to the top of the container, and then I want it to condense at the top to help the nucleation process when it meets with the particles of the aerosol can, dust from the aerosol can. Okay, so I have my water. I really hope this shows up for you all today, that you're able to see it. Yeah, that water should be plenty hot. It might be exactly what I told you not to do, maybe too hot. Okay, it doesn't look too bad. Let me Try to get rid of some of this. What you're seeing there on the side is condensation. That is not my cloud. Again, I want to make that distinction. The cloud will form as a result of dust being here. So I'm just going to put one little spray in here. All right, that is my dust. All right, and you see how little spray I needed to use. Now, moment of truth. Let's see if we get this to work. It is working. I hope you can see it. Maybe if I put a background. And I hope you're trying this also at home. So on the inside, what's occurring, what I can see, and I'm not sure if you're able to see it, but I can see on the inside that there's like streams of white dropping down from the top back into the container. And that is my cloud. I hope you're able to see it. And in fact, I hope that if you're at home, that you're able to get this to work for yourself as well. I will say I have done this many times, and so I've practiced just getting it just right. So challenges to making this particular demonstration work include having water that is too hot, not filling the water up far enough. Okay, because remember the water there's moisture that needs to rise up to the top in order for this to work. So if you only have a little bit of water at the bottom, it's just going to take longer, or it's going to be a little harder for all that moisture to get to the top as fast. And so I do try to fill up almost a halfway mark on my container. I probably should have added a little more water so it's present. But yeah, the other thing that is a challenge is making sure that your lid is already cold. So if you do this and your lid is warm, you put ice on it, it might work, but it won't work as effectively or as quickly. Okay, I do want to see if the folks on Instagram are able to see that. It's a little bit, it's tricky to see with these cameras. Again, I have done this as a demonstration on my YouTube channel. I have a video, it's called Cloud in a Jar. And you can very clearly see the streams of white dropping down from the top. And that is my cloud on the inside of the jar. All right. The earth itself is constantly being heated by the sun. And I mention that because what happens, how the moisture gets in the atmosphere in the first place is the oceans, the waters, the rivers, the lakes, the streams are being affected by the sunlight each day. The heat from the sun is causing the water in those bodies of water to evaporate and get up into the atmosphere. All right. And often you see the worst kinds of weather conditions tend to happen after a weather system has come across a large body of water. For me, growing up on the western side of the state of Michigan, there would be a weather system coming from Wisconsin. And as soon as it would pass over Lake Michigan, you could watch the radar. The weatherman will show you the Doppler radar, and you will see this green on their screen in Wisconsin that indicated light rain. As soon as it begins to pass over Lake Michigan, you will start to see those green colors turn yellow and orange and then red, indicating that there was a severe weather system coming for the western half of the state of Michigan. The effect of that water heating definitely affects the way weather occurs or behaves. We also see this in the tropics. For example, when we see a hurricane, the warmth of the water strengthens the hurricane. Okay, so that has an effect. Well, Earth is constantly being heated, and that's causing things to go up, water moisture to be evaporated up into the atmosphere, and that captures or is connected to those dust particles, and that causes our clouds. In the jar today, we have something like that where we have hot water that is evaporating upward on the inside of the jar. So it's kind of like being a representative of what's happening on the ground is where this hot water is, and at the top is like the atmosphere. So you can think of it in that way. So again, I hope you're trying this at home. I hope you get it to work, and I actually do hope you're able to see it on camera there. If not, again, check out my YouTube channel. I definitely have a much better camera and a better camera angle that I recorded that with, so you can clearly see it there. The streams, what you'll notice is there's streams of white that are kind of dropping down from the top. Not the condensation that's sitting on the side of the jar, but you'll see the streaming white coming down. That is the cloud that you're making on the inside of the jar. All right, so I hope that you learned something about weather, about meteorology, and about clouds today. That wraps up the third week of these lessons. And I will be back again next week. I haven't put the syllabus quite together yet. I have some ideas, but I hope to have that all posted sometime Saturday, certainly by Sunday, what we'll be doing next week. I will see you each day at 2 p.m. Eastern Time. In the meantime, you can check out some more videos. I have posted the past 2 weeks of videos that we've done live stream. I've posted all of those lessons on my YouTube channel. So you can go back and review what we've done for the past 2 weeks, or maybe you missed a lesson one of those days. You can go back. I have them listed underneath Homeschool Science Lessons, week 1, week 2. I'll post week 3 on Thursday morning. Also, I have a new video coming out for Monday morning, and I can't remember what the topic is, but definitely want to check that out. You can find me on Instagram at science-made-simple_LLC. Definitely tell a friend. We're doing these lessons. If people have children at home that they want to learn while most of the nation is underneath lockdown, definitely take advantage of this. I really hope that I'm helping, and I hope you're learning something. All right. I will see you next Monday. Take care. Have a good weekend. Oh, and happy Good Friday.